Okay, this is lecture for week 16, and this is just a collection of miscellaneous topics related to cloud forensics that are important to know about or think about. And first, the list of what we're going to talk about. We're going to talk about container forensics, cloud storage forensics, timeline reconstruction in the cloud, cloud networking forensics without having PCAP capabilities, anti-forensics in the cloud, and cloud incident response versus traditional incident response. So the first is container forensics. So containers are an isolated way to run programs or applications in what we refer to as a containerized environment. One of the most popular pieces of software dealing with containers is Docker. Now, these create some issues when we're trying to do forensics. The first is they're ephemeral in nature. That is, we start them up, they do whatever they're supposed to do, and then they go away. So that causes a lack of persistent data. And also, often when you're running containerized applications, you'll have a distributed environment where the containers are running on different servers or different cloud providers, for example. There can also be logging inconsistencies. By that, we mean they may be configured differently, they may store different informations, and then what I'm calling tooling limitations. And what that means is traditional forensic tools that we've been discussing were not designed for containers. So we need a new set of specialized tools and skills to investigate this type of evidence. As far as cloud storage forensics, this really comes down to collecting logs that are from cloud storage services. Some of the issues that we have with cloud storage would be limited investigator access. The data may be distributed amongst different locations or different services. A lot of times clouds are multi-tenancy, which means our data is on machines with other organizations' data. We may have logging limitations as to what's logged or how detailed the logs are. And because these are running on a cloud provider's services, we have chain of custody concerns, and most of the time what's called data at rest, which is data sitting on a storage system, is encrypted. So we have to deal with that. And then also, because these are in the cloud and we may be running on different data centers in different locations in the United States or possibly other countries, we have jurisdiction and legal challenges that we have to deal with. As far as timeline reconstruction, this in general is the same as what we've talked about in the past, which is gathering evidence and trying to figure out a timeline. And the timeline, of course, is what happened, when did it happen, and in what order. Some issues with this, we've talked about time synchronization issues a couple of times. That can be a challenge. Also, these services and or data may be distributed across multiple services within a single cloud provider or even possibly multiple cloud providers. The logs may be incomplete and or missing, and the formats may be inconsistent. What that means is what data is stored and in what order, etc., may be different from service to service. And the problem with logs in general is often they're really big. So we have to store that data, we have to pay for that data, and it takes time to go through and extract the data needed to create a timeline. And all this is dependent upon the logs that the provider has given us. And then in general, event correlation can be very complex. But if you add all the things in this list, it's complex, time consuming, and sometimes difficult to figure out. Believe we've talked about this in the past, but since we cannot access the bare wire, we cannot create and or save a packet capture with something like Wireshark. And the issues is we do not get the same level of detail that we might get on a physical machine where we've run Wireshark or TCP dump. We are reliant upon flow logs. This gives us limited visibility into attacks. Often this traffic is encrypted. We may or may not have complete logging. And then there are timing and granularity issues because with a flow log, for example, things are kind of grouped together. So things that occurred over multiple seconds or minutes may be grouped together. So you don't have down to the second or down to the millisecond timestamps, for example. And like all correlation, it is difficult to figure out what was going on because of the first item, which was lack of packet level details. Anti-forensics is the hiding, altering, and or destroying of evidence in the cloud to try to hide your activity and make it difficult for somebody doing a forensic investigation to gather evidence and or create a timeline, etc. So issues with this is often it is easy to delete evidence. Files that were created, log entries that were made. A hacker, for example, could delete those. Likewise, they can alter logs, they can tamper with them, they can turn logging off so that their activity is not being logged. They can use ephemeral resources knowing that they can do whatever hacking or data compromise or security compromise they want to do, and then any evidence of that will go away if they use ephemeral services. Encryption abuse, that's just encrypting data that normally wouldn't be encrypting it multiple times, etc., to make it hard to figure out. We can have or use obfuscation techniques. This would be things like using multiple accounts, rotating IPs, using anonymization tools, etc. And then when we talk about the shared responsibility, there may be gaps or confusion in who's responsible for what, and a hacker can exploit that, hoping not to be caught. And the investigators, because this is in the cloud, and ultimately these services are under the control of the cloud service provider, you have limited visibility into the entire environment. Continuing on, rapid scalability. So you can fire up a bunch of machines to do an attack and then have them go away. possibly before anybody is able to collect evidence related to the attack, often even before they know the attack is occurring. A lot of times metadata is stored. They can alter that metadata so that it's harder for you to figure out what went on, or to basically mess up or make a fictitious timeline. They can abuse legitimate cloud services, for example, to try to do a denial of service or something like that. Sometimes the logging is delayed and or asynchronous, which can complicate matters when you're trying to very promptly figure out what's going on. Often we do snapshots and backups to protect ourselves. A hacker may go in and change those backups to hide information or make things look different than reality. And they can abuse identity and access tools and services to try to hide who is doing what. So that was just some additional topics that you might need to be aware of and think about related to cloud forensics.